Hi, today I am presenting my Kafka-based order processing system for the big data module assignment. Today I will demonstrate a complete uh, real-time order processing system that meets all the assignment requirements. When we come to the requirements, the first requirement is Euro serialization for message schema, and the second requirement is real-time price aggregation with earning averages, and the third requirement is retry logic with exponential backoff, and the fourth requirement is DLQ for fail messages. That means dead letter uh, queue. Then let me show you how this system works. And when it come to the project structure, so first I want to show the order schema. Uh, that means order.avsc file. So, in order schema, it defines the euro schema with the order ID, product, and price fields, and the euro provides efficient binary serialization and schema evolution. Then I want to go to the producer JS. Yeah, here the producer JS, and when it comes to the producer JS, it generates random orders with euro serialization, and it will publish us to the orders topic. So then when it comes to the consumer, that means the consumer.js, the consumer consumes orders with retry logic, and consumer calculates real-time price averages, and the consumer also can handles failures with DLQ, that means dead letter queue. So finally, I want to go to the Docker compose.yaml, and in here there is Docker setup, and in here we can see Kafka cluster with Zookeeper, and we can see also the Kafka UI for monitoring tasks. So this is all about the project setup, that means files. Then I want to come to the system setup. Okay, so let's start the system. First, we have to start the Kafka and Zookeeper using Docker Compose. So for that I have to type the Docker Compose code, and when I press enter, you can see all the containers are created and running. And so now we have to verify the services are running properly. For that, I have entered that Docker Compose PS code, and when I press enter, you can see the Kafka and Zookeeper have run successfully. Let's run the consumer, and for that for that I open both terminals for consumer and producer for the clear visualization, and for the consumer I have to run npm run consumer.js. uh, so when I press enter, there is an error because consumer is waiting for loading the producer, but still we don't load the producer, and that's why there is an error. And then we run the producer. For that, in the other terminal, we have to type npm run producer.js. So when we enter, you can see the producer is running successfully, and you can see the producer sending orders, and here it is keyboards, webcam, and headphones, phones, tablets, and those kind of things, and each order has a unique ID and some prices. These prices are random prices. Now we look at the consumer terminal. You can see consumer successfully receiving and processing these orders in real time. And notice that the running average price calculation being updated with each process orders. And now you can see the consumer and producer running successfully. And then I'm going to show you how I did the error handling part. Uh, so so I want to demonstrate my error handling part. So the key requirement of this system is the error handling. That means the retrying error handling and DLQ error handling. So to demonstrate retry error handling, in here there is some retry error handling. So in here you can see what happened here. The system automatically retries. That means you can see the retry counter. So the system first retry 1 out of 3. So the first time it fails, but in the second time the order 122, the order of headphones, it can go to the consumer, and in the second time it successfully go to the consumer side. So that is the retry error handling. So then I want to show some DLQ error handling. So let's see. Um, yeah. So when it comes to the DLQ error handling, in here the producer tries uh, 3 times. 1 out of 3, 2 out of 3, and 3 out of 3. So after the 3 times, the producer send to the DLQ, and there is a message. And in here you can see price exceeds threshold. That means that 3 times. So so after fails all the tries, it go to the DLQ, and there is a message. And after maximum retries exceeds the DLQ message, the system send a DLQ message, and that DLQ message includes metadata like the error message and the original topic and the timestamps also. Uh, so in production level, these DLQ messages would be reviewed by engineers and reprocessed after fixing underlying issues. So that's why the DLQ error handling is very important. Yeah. So this is all about the big data, the first assignment. And as a summary, I showed you what are the requirements and what are the important files and what are the and how I did the retry error handling and DLQ error handling after 3 failures. And to clean up the system, I type Control C to terminate the consumer and producer. Yeah, so I type it. Yes, also, and in the producer side also. Yeah, and so I can clear all the Kafka and Zookeeper by typing consumer, Docker compose down. So this is all about the first assignment of big data, and thank you for watching.